to know what the quadrantal angles look like. So for example, if you're doing your positive degrees, here's your 0 degrees, 90 degrees, 180, and then 270 degrees. And then one complete revolution all the way around is 360 degrees. So if you're labeling in the negative direction, again, you're still starting at 0 degrees. Here's negative 90. Here's negative 180. And here's negative 270 degrees. And then again, one complete revolution is going to put you back at 0 degrees, which is negative 360. So when you're sketching your angles, it's sometimes helpful to know what the quadrantals look like. In radians, if you're dealing with positive radians, here's your 0 radians. Here's half a pi, or pi over 2. Here's a whole pi. Here's 1½ pi, or as an improper fraction, 3 pi over 2. And then one complete revolution would be a complete 2 pi. For negative radians, here's 0 radians. Here's negative pi over 2. Here's negative pi. Here's negative 3 pi over 2. And obviously one complete revolution around would be negative 2 pi. Okay? Now, as I mentioned when we were going over one of your homework examples, there's 2 ways you can label radians. When you have pi in your answer, these are exact. These are exact angles. The minute you multiply your pi out, they're no longer exact. These are approximate. And that's just basically taking your calculator and multiplying out the pi symbol. So in approximate radians, when the pi is multiplied out, again, starting at 0 radians, pi divided by 2 as a decimal is approximately equal to 1.571. Pi is about 3.142. One and a half pi, or 3 pi over 2, is 4.712. Two pi is about 6.283. So pi over 2 is a decimal. That's what pi over 2 is equivalent to. I've just multiplied the pi symbol out. So radians can be expressed, like I said, remember, as either approximate or exact. So as negative radians multiplied out, here's 0, negative 1.571, negative 3.142, negative 4.712. Okay. But just remember, sometimes, especially when you're doing your sketches, it's helpful to know what the quadrantal angles are. All right, let's talk about reference angles. And we've actually looked at reference angles when I had you introduce the unit circle. So the definition of a reference angle, remember, coterminal angles is when I'm adding or subtracting 360 to help me find a different angle measurement. Reference angles, it's always the positive. It always has to be positive. And by the way, what does the word acute mean? Less than 90. So reference angles always are positive and acute. And they're formed by the terminal side of theta and the x-axis. So what you're doing, you're no longer just using that one planted side, the initial side of the angle. You're finding the distance between the terminal side and the x-axis. That's what the reference angle is. And that's why it's positive. We talk about distance, we're always talking about positive. So for example, if you have an angle in quadrant 1, the reference angle is the distance between the terminal side and the x-axis. It could be the positive x-axis or negative x-axis. This measurement here is your reference angle. So for example, if I ask you to find the reference angle for 30 degrees. So if I sketch 30 degrees, there's my 30 degrees. So quadrant 1's unique. As long as your angle is already between 0 and 360 degrees, your angle is its own reference angle. Because notice the distance between the terminal side and the x-axis is 30 degrees. So the reference angle then is the same as your initial angle of 30 degrees. So theta prime is referring you to the reference angle. But the reference angle measures the distance between the terminal side and the x-axis. So as long as your original angle is already between 0 and 360, then your theta value, if you're in quadrant 1, is its own reference angle. So now let's take a look when you get out of quadrant 1. Let's take a look at quadrant 2. So to find the reference angle is the distance between the terminal side and the x-axis. That's your reference angle right in here. And we are doing the unit circle. You guys in your mind were starting to do this in your heads. How did we find, for example, if I asked you for the reference angle, let's say of 120 degrees. Well, here's my 120. You guys in your mind were doing this on your own. How would you find the distance between the x-axis and the terminal side? What would you do with 120 degrees? Subtract it from what? 180. That's exactly what you do anytime you're in quadrant 2. I would take 180 degrees and subtract it from 120. So what would my reference angle be? My reference angle would simply be what? 60 degrees. So my general statement then, to find a reference angle in quadrant 2, I'm going to take 180 degrees and subtract whatever that angle is. Or if it's in radians, it's going to be pi minus theta. Because some of these may be in radians. Again, this rule only works if your angles given are between 0 and 360 or 0 and 2 pi. So the angles that are given, these rules are only going to work if the angle I'm asking you to find the reference angle for are already between 0 and 360 or 0 and 2 pi. So now let's go down into quadrant 3. So my reference angle, remember, is always the distance between the x-axis and the terminal side. This is your reference angle. So for example, if I want to find the reference angle, let's say, of 230 degrees. Well, if I sketch 230 degrees, I do have an angle down here in quadrant 3. This is the angle that I'm trying to find. Any thoughts on how I'm going to find the distance between the terminal side and your x-axis? 230 minus 180, exactly. 230 minus 180. That would have actually given you the distance between the y-axis and the terminal side. What's 230 minus 180? 50. So then my general statement is, what I can do is I can take the angle that's given and subtract 180 degrees from it. Or I can take theta and subtract pi from it if I'm in radians. So in quadrant 4, the reference angle, again, is the distance between the x-axis and the terminal side. It's that angle right in there. What are your thoughts? What do you think you're going to do to find that particular angle? Subtract it from what? 360. So it's going to be 360 degrees minus the angle that I'm asking you to find the reference angle for. Or if I'm in radians, it'll be 2 pi minus theta. So for example, let's talk about 320 degrees. So 320 degrees I know is up down there in quadrant 4. There's 320. My reference angle, again, is that distance between the x-axis and the terminal side. What's the reference angle then going to be for 320? 40 degrees. Always know your location. Location, location, location is key. So you'll want to sketch your angles first to decide what you're going to do in order to find the reference angle. So now let's talk about number 1. Where is 60 degrees going to be located? What quadrant? Quadrant 1. So here's 60 degrees. What's the reference angle going to be? 60 degrees. Remember, in quadrant 1, as long as this angle is between 0 and 360, you're at your own reference angle. Okay? So now let's take a look at number 2, 140 degrees. What quadrant is 140 degrees going to be located? 2. So there's 140 degrees. The reference angle I'm trying to find, remember, is the distance between the x-axis and the terminal side. So what am I going to do to calculate the reference angle? What am I going to do with 140? 180 minus 140. So the reference angle is going to be what? 40. Remember, reference angles have to be 2 things. They have to be positive and they have to be acute, less than 90 degrees. Reference angles are always positive and less than acute. And they have to be acute, less than 90. Okay? You guys go ahead and try 3 for me. Yes, Sophia? Yeah. Sketch 220 and find the reference angle. Let's talk about number 4. Where is what quadrant is 340 degrees going to be located? 4. So what do I do to calculate that reference angle? What do I have to do with 340? 360 minus 340, so the reference angle will be 20 degrees. So as long as my angle measurement was in degrees, and my angle was already between 0 and 360, it's really not that challenging to find the reference angle. You all agree with me? Let's go down, and let's, actually before we talk about radians, I'm going to give you another example. We're going to change number 5 to 500 degrees. If I'm asked you to find the reference angle, and the angle is greater than 360 degrees, the easiest way to find the reference angle, now that you know how to find coterminal angles, find the coterminal angle that's between 0 and 360 degrees, because as you saw, it's not too difficult to do, as long as the angle is between 0 and 360. So tell me what the coterminal angle is going to be for 500 degrees. Remember, that's what you did last night for homework. 140 degrees. Remember, 500 degrees and 140 degrees are located in exactly the same spot. So find your coterminal angle first between 0 and 360. What quadrant is 140 degrees located? 2. Remember, 500 degrees is just 140 degrees, but with one additional rotation. So then, as you can see, the reference angle is just simply going to be what? 40 degrees. So any questions on how you're going to handle an angle in degrees when the angle is greater than 360? Let's look at 2 pi over 3. Is it one of our special angles from the unit circle? Yes. Where is 2 pi over 3 located? Quadrant 2. Same rules apply. What did I do in degrees? In degrees, if it was a quadrant 2, I took 180 and I subtracted 2 pi over 3. Well, what is 180 equivalent to in radians? Pi. So I'm just simply going to take pi and subtract from it 2 pi over 3. Remember, pi is actually a fraction over 1. So what's pi over 1 minus 2 pi over 3? Well, again, this is actually, I can change this into 3 pi over 3. What's 3 pi over 3 minus 2 pi over 3? Pi over 3. So my reference angle is just simply going to be pi over 3. Yeah, Phyllis.
So, for the second spectrum, unit circle one, do you just convert it into degrees and do it that way, or do you still want in radians?
Well, if the original angle is given in radians, your final answer needs to be given in radians.
Okay.
Again, if you're having to convert things into degrees, that's fine, but you just want to make sure you're consistent in converting in the end. You want to be consistent. All right, let's take a look at number 7. Where is 7 pi over 6 located?
4.
Quadrant 3. You're getting there. So there's 7 pi over 6. Remember, my reference angle is the distance between the terminal side and the x-axis. So again, in degrees, you told me I was going to have to take my angle and do what with it? Subtract out what? 180. So instead of doing 180, what is 180 equivalent to in radians? Pi. So I need to take 7 pi over 6 and subtract pi. So I need to get the common denominator, 7 pi over 6, minus 6 pi over 6. So what's the reference angle going to be for 7 pi over 6? Pi over 6. So any questions on number 7? Let's take a look at number 8 for a minute, because this isn't on the unit circle. Is 9 pi over 5 less than 2 pi? No. So again, 2 pi with a denominator of 5, what is that equivalent to? 10 pi over 5. So those of you that weren't sure, is 9 pi over 5 less than 2 pi? Yes, so I know that I'm already between that 0 and 2 pi range, aren't I? So, thinking about fractions, without having to convert into degrees, I know 10 pi over 5 is one complete revolution. What quadrant do you think 9 pi over 5 would be located? 4. Bingo. Save yourself some work.
So it doesn't have to be like the exact.
No.
If you know, like, the number.
You need to know what quadrant you're in. So now, my reference angle, remember, is the distance between the terminal side and the x-axis. So remember when we were doing this in degrees, if I was in quadrant 4, I took my angle and I subtracted 360 from it. Well, what's 360 equivalent to in radians?
2 pi.
2 pi. So all I'm going to have to do is I'm going to have to take 2 pi, which I already know is 10 pi over 5. 10 pi over 5 minus 9 pi over 5. Pi over 5. There's your reference angle. I'm trying to get you guys to think about radians a little bit more than constantly having to convert things into degrees and then converting things back. The goal is to be able to get your brains to start thinking more and more in radians. It is okay if you have to do the conversions right now, but again, it can be time consuming. You can open yourself up to an error. All right, so the more comfortable you start feeling in radians, the better off you're going to be. Let's take a look at 9. 7 pi over 3. So the question is, 2 pi over 1 with a denominator of 3. With a denominator of 3, what is 2 pi equivalent to? 6 pi over 3. So where am I here? Is 7 pi over 3 bigger than 2 pi or less than 2 pi? Bigger. So remember, when you're trying to find reference angles and the angle given is greater than 2 pi or greater than 360, find your positive coterminal angle between 0 and 2 pi. So remember, what you're going to do is you're going to take 7 pi over 3 and subtract 2 pi from it. And what does that leave me with? 7 pi over 3 minus 6 pi over 3. Pi over 3. So when I sketch 7 pi over 3, what quadrant is that terminal side going to be located? 1. But I know that 7 pi over 3 just has one complete revolution with it. What is the reference angle then going to be? I'm in quadrant 1, so what's the reference angle going to be? Pi over 3. So as long as you can get that coterminal angle between 0 and 2 pi or 0 and 360, hopefully finding that reference angle isn't too difficult for you. Any questions on that? Look at 17 pi over 6. Well, first of all, the question is 17 pi over 6 larger than 2 pi? Because 2 pi is equivalent to what with a denominator of 6? 12 pi over 6. So you all agree with me that 17 pi over 6 is larger than 2 pi. So then I know when I sketch 17 pi over 6, I'm going to make one complete revolution. So when I take 17 pi over 6 and subtract 12 pi over 6, how much further do I have to go? 5 pi over 6. So thinking about your unit circle, what quadrant is 5 pi over 6 located? 2. So there's 17 pi over 6. So here's my reference angle. Again, remember, 5 pi over 6 is in exactly the same location as 17 pi over 6. They're going to have the same reference angle. How do I calculate the reference angle there in quadrant 2? What am I going to do with 5 pi over 6? I'm going to subtract it from what? Pi. So pi, which is actually equivalent to 6 pi over 6, minus 5 pi over 6. So then what's the reference angle going to be? Pi over 6. So any questions on finding the reference angles? Okay. Let's go down and let's take a look at 13 on the back. Depending upon how your brains are thinking right now, some of you are a lot more comfortable with negative angles than some of us. Some of you may be able to see what quadrant negative 3 pi over 4 is going to be and how to find the reference angle. But if you're not sure that those negative angles are still throwing you off, you can find the positive coterminal angle. All I need to do is add 2 pi to this to get a positive angle measurement. If the negative angles are making you feel uncomfortable, find the positive coterminal angle. So negative 3 pi over 4 plus 8 pi over 4. So what would my positive coterminal angle be for negative 3 pi over 4? It's going to be what? 5 pi over 4. Negative 3 pi over 4 and 5 pi over 4 are going to have exactly the same reference angle because they're in the exact same location. What quadrant then would 5 pi over 4 or negative 3 pi over 4 be located? 3. So there's that negative 3 pi over 4. 5 pi over 4, remember, is just going in this direction. My reference angle is still the same. So like we've been doing, if you're in quadrant 3, what would I do with 5 pi over 4? I would just simply subtract a pi from it. So that's going to just give me pi over 4. Where's negative pi over 7 located? What quadrant do you think negative pi over 7 will be located? 4. Again, if you're not comfortable working in negatives, I could add 2 pi to this, which would give me 13 pi over 7. 13 pi over 7 would be that angle there, going in the counterclockwise direction. 14 pi over 7 is 2 pi, but I subtracted the negative pi over 7. What do you notice about the reference angle? What's the distance between the x-axis and terminal side going to be here? Pi over 7. Okay, so any questions on finding reference angles? Okay, I want you guys to take out your laptops.